All right, we're going to keep talking about polygons. This is lesson 11.3, and this is part 3. We've learned what a polygon is. We've learned how to name polygons according to the number of sides. And now let's talk about how can we figure out the measure of the interior angles of any polygon. Let's go back to our knowledge from our lesson on triangles. We know that the sum of the angles inside any triangle is 180 degrees. And that knowledge about triangles is really going to help us when we look at any type of polygon. Because it turns out any polygon, whether they're regular or irregular, we can tile, if you will, triangles inside that figure. So let's start over here with our quadrilateral, our four-sided polygon. If I go to any vertex and I draw a straight line segment across to another line segment, I have now represented that quadrilateral as two triangles that are just side by side. So what we know is, I'll change my colors here for just a second, we know that the sum of the angles inside this triangle is 180 if I add up all of these, and we know that the sum of the angles inside this triangle is also 180. So the sum of the angles for the entire quadrilateral is 180 plus 180, and that's going to equal 360 degrees. And that actually ends up being the truth for any quadrilateral. The sum of the interior angles is always 360 degrees. That kind of makes sense. We know that a square is made up of four 90-degree angles. We can totally understand that the sum of the angles inside a quadrilateral is 360 degrees. Well, let's use this triangle idea, and let's look at this pentagon. This is an irregular pentagon, and I'm just going to start from one corner here, and I'm going to go from that vertice to this vertice, and from this same vertice down to this vertice. So this is a five-sided polygon, and this five-sided polygon has 1, 2, 3 triangles inside of it. Let's see if you can figure out how many. I'll draw an octagon. I like to draw my octagons by blowing up a square and then connecting the sides. I don't know if that makes sense to you or not, but that's how I draw my octagon. And I'll take my red pen back. I'm going to start from one corner, and I'm going to go across, and I'm going to break this octagon into a set of triangles. And so now I can add them up. Ooh, I forgot one right here. If I was better at drawing, let's see here. I have one more right here. Okay, so how many triangles do I have inside this octagon? 1, 2, 3, 4, 5, 6. So an 8-sided polygon has 6 triangles inside, and a 5-sided has 3 triangles inside. Are you figuring out that the number of triangles that we can tile inside a polygon is always equal to the number of sides, so the sides minus 2, right? 5 minus 2, that tells us that we have 3. 8 minus 2, that tells us that we have 6. And we can use that to help us figure out the measure of the angles inside any polygon. So here it is. The measure of the interior angles of any polygon is always equal to the number of sides, so we'll use S minus 2 times 180 degrees, because this is the number of triangles, and this is the measure of angles inside every single triangle. So side minus 2 times 180 is always going to help us figure that out.